You've probably seen those big rigs with exhaust pipes like this. A pair of chrome stacks towering majestically behind the cab, pointing straight to the sky like industrial smokestacks. And you've probably thought it was purely for show or something truckers do just to customize their rigs and stand out. And you've probably thought that because you've also seen other trucks with their exhaust pipe down below, discreetly tucked away under the chassis. The truth is, the reason is far more interesting and complex than it first appears. It leads us to understand two trucking traditions that grew up in completely different worlds, on separate continents, and that inadvertently defined how the trucks we see on the road today look, sound, and operate. But before we reveal all the secrets behind this engineering decision, and if you're fascinated by understanding how things work, hit the like button and subscribe to the channel for more content like this that reveals what goes on behind the scenes. Okay, let's start uncovering the truth, the birth of the chrome stacks. To begin, you have to remember something fundamental about heavy-duty truck construction. The underside of a heavy-duty truck is packed to the absolute limit with critical components. The reinforced chassis, cross-members, massive fuel tanks that can hold up to 264 gallons, compressed air lines, a complex suspension with multiple articulation points, high-capacity batteries, it all fiercely competes for limited space. On top of that, all of it generates intense heat, vibrates constantly with every bump in the road, and leaves very little room to install a system as hot and delicate as the exhaust, which can reach temperatures over 900 degrees Fahrenheit. In that complicated context, routing the exhaust upward made perfect sense from a practical standpoint. It moved it away from the congested chassis, prevented it from getting hit by rocks or debris on unpaved roads, and kept it clear of puddles and standing water on poorly maintained highways. It also expelled toxic fumes above the flow of pedestrians and other vehicles, reducing annoyances and risks in dense urban traffic. That's why, in the early 1940s in North America during World War II, the vertical exhaust wasn't a passing fad. It was a practical solution to real engineering problems, and over time, it became an essential part of the American truck's visual identity. Just like those enormous cylindrical external air filters you still see on classic models. The history is fascinating because in the 1930s, trucks had exhausts that exited from the side of the engine, similar to cars, but drivers constantly reported problems with smoke getting into the cab. This was especially true on long uphill climbs where the engine worked hard and expelled more fumes. Engineers tried several solutions. Some attempted exhausts that ran underneath the engine, but those were constantly damaged by rocks and potholes. Others tried exhausts that exited behind the chassis, but those dangerously heated the rear tires. Finally, an engineer whose name has been lost to history had a simple but brilliant idea. Why not send the fumes upward? Away from everything. And the first prototypes were tested on military trucks during the war, and they worked so well that after the conflict, civilian manufacturers quickly adopted the design. Fun fact number 1. The original vertical exhausts in the 1940s weren't chromed or decorated. They were painted black steel pipes that rusted quickly. The shiny chrome we associate with classic trucks didn't become popular until the 1960s when independent truckers began customizing their rigs as statements of professional pride and a way to stand out on the road. But wait, that's not all that motivated this historic decision. There was another, even more decisive reason, directly related to deafening noise. The first heavy-duty diesel engines, especially the legendary two-stroke Detroit diesels, were brutally loud and deafening. And a Detroit 5.8 sounded like 16 cylinders firing at once, which is why they were nicknamed Screaming Jimmies. The Jimmy part came from GMC, General Motors Corporation, which built these engines. But the screaming was totally deserved. These engines were so loud that drivers were required to wear earplugs. Medical studies from the 1950s showed that truck drivers who operated Detroit diesels suffered from premature hearing loss. And of course, adding a more restrictive muffler would rob them of too much valuable performance. Two-stroke engines need free-flowing exhaust to operate efficiently. A restrictive muffler could reduce power by up to 20%. That was unacceptable for truckers who needed every last horsepower available. So, the only way to maintain some level of auditory sanity was to send the exhaust up and as far away from the driver's cab as possible. The distance helped disperse the sound before it reached the driver's ears. It didn't eliminate it, but it made it tolerable. Some veteran truckers say you could identify a Detroit diesel from miles away just by the sound. A continuous shrill roar that was unlike any other engine, and there are more technical reasons that engineers discovered over time. In trucks with integrated sleeper cabs, where the engine had to stay running for hours to power the climate control, it was critical to keep the exhaust fumes away from the space where the driver slept for several hours. The elevated stacks solved that perfectly without requiring complex systems, and they dispersed carbon dioxide and particulates at a safe height, far from human respiration. There was also a significant thermal benefit that engineers discovered. By being completely exposed to the ambient air, the vertical exhaust cooled down much more effectively, which was vital for giant engines expelling enormous amounts of gas at extremely high temperatures. Furthermore, keeping the exhaust up high prevented interference with the rear suspension, the flexible chassis, and heat-sensitive components. This significantly reduced the risk of fire and freed up the space below for other systems that absolutely needed to be there. Fun fact number 2. During World War II, American military trucks used vertical exhausts primarily for crossing deep rivers and fords, and the elevated exhaust prevented water from entering the engine when they drove through water up to 3 feet deep. This military practice directly influenced the design of later commercial trucks. As you can see now, the vertical exhaust wasn't just a baseless aesthetic choice. It solved issues of noise, safety, truck layout, and cooling all at once. That's why it ended up becoming a cultural symbol. For many traditional truckers, removing those stacks is like taking away part of the truck's character. It's part of its visual identity. But since the world of trucking is much broader than North American highways, in regions with narrow streets, tight turns, and quart cab-over-engine trucks, especially in densely populated Europe, the vertical exhaust simply doesn't work physically there. As anything sticking up vertically can hit low structures, get snagged in low-clearance tunnels, or reduce necessary overhead clearance. That's why European trucks, almost always the cab-over-engine type, they need to make use of every inch without anything getting in the way or sticking out unnecessarily. And that's where the star of the modern era comes in. The discrete, horizontal exhaust. The European horizontal revolution. Its advantage isn't just its compact size. It's the carefully calculated, superior aerodynamics. European manufacturers want the back of the cab to be as close to the trailer as possible to smooth out turbulent airflow. That gap is critical for efficiency, and any vertical element like a smokestack creates massive turbulence and needlessly drives up fuel consumption. Therefore, a horizontal exhaust, well integrated into the chassis, cleans up the aerodynamic profile, and it allows the air deflectors to do their job without obstruction. The air flows better over the entire rig, fuel consumption drops, and the entire truck becomes more energy efficient. And if that sounds logical from a technical standpoint, wait until you hear the financial part that really changed everything. In Europe, diesel is much, much more expensive than in the United States. We're talking about almost double the price per gallon in some countries. Every bit of efficiency counts financially. That's why engineers reduce gaps, compact the entire setup, and eliminate anything that creates aerodynamic drag. In fact, it's estimated that a low-roof truck with a vertical exhaust and no deflector can consume over 5% more fuel than one with a horizontal exhaust and well-designed deflectors. And in commercial transport, 5% is an insane amount of money, especially when you multiply it by the number of trucks an international company might have. Imagine a company with 200 trucks. Each one travels an average of 93,000 miles per year. A 5% difference in consumption means thousands of gallons of fuel wasted annually. Fun fact number 3. A modern European truck with a horizontal exhaust can save up to 400 gallons of diesel per year, compared to one with a vertical exhaust and no aerodynamic optimization. In a fleet of 100 trucks, this represents a savings of over $200,000 annually just in fuel. The numbers don't lie, and company accountants know it. That's why in Europe, it's rare to see vertical exhausts on new trucks. It simply doesn't make economic sense. And here's another factor that many don't consider: total weight. A complete vertical exhaust system, with its supports, reinforced clamps, and extra piping, can weigh between 110 and 175 pounds more than a horizontal one. It doesn't sound like much, but in Europe, where weight regulations are strict, every pound counts. Less weight on the truck means more payload you can legally transport. So as after-treatment systems grew in size and complexity, SCR, DPF, DOC, engineers began to value every curve, every pound, every inch of available piping. But before we continue, let me give you some quick context on what exactly an after-treatment system is and why it has so drastically changed the way a modern truck is designed. An after-treatment system is basically the set of devices responsible for cleaning the gases that leave the engine before they reach the atmosphere. In the past, the exhaust just spewed smoke directly without any filters. Today, due to strict environmental standards like Euro 6 and EPA 2010, that smoke must pass through several filters and chemical reactors that reduce pollutants. And all of those components need considerable space. The DPF, or diesel particulate filter, captures solid particles. The SCR, or selective catalytic reduction, uses liquid urea to convert nitrogen oxides into nitrogen and water. The DOC, or diesel oxidation catalyst, oxidizes carbon monoxide and hydrocarbons. All this equipment can take up the space of a small engine, and it must operate at specific temperatures. They need piping routes that are as compact as possible to work well and maintain temperature. Packaging these systems under the chassis makes it easier to maintain the necessary heat to regenerate the particulate filter. In contrast, a vertical exhaust requires much longer pipes from the turbo, which seriously complicates thermal management. It adds dead weight, adds more potential points for gas leaks, and therefore adds costly maintenance. Longer piping means more heat loss. And the system needs heat to function efficiently. That's why engineers prefer short, direct routes. Fun fact number 4. Modern aftertreatment systems can reach temperatures of over 1,100 degrees Fahrenheit during the regeneration of the particulate filter. This is why some trucks warn drivers not to park near flammable materials during this process. Moreover, these systems require constant monitoring from sensors: temperature sensors, pressure sensors, NOx sensors, oxygen sensors. Each sensor is a potential point of failure. The more compact the system, the easier it is to monitor and maintain. A vertical exhaust with long piping means sensors are distributed in hard-to-reach areas. A horizontal exhaust concentrates everything in one accessible area under the chassis, as you see now. And it's no coincidence that more and more trucking companies are requesting it, and that manufacturers are incorporating side or rear-facing outlets depending on the type of operation and specific local regulations. Even traditionally, American brands like Kenworth and Peterbilt now design their trucks with a horizontal exhaust as the primary configuration. The vertical stacks are added later as a nostalgic option, the unbreakable cultural factor. Still, after everything we've told you, the cultural weight of the vertical exhaust is still alive and well in North America. In the United States, exhaust stacks are and will continue to be a symbol of freedom and tradition. Some pickup truck owners even install vertical stacks just for aesthetics, even though it offers no practical benefit. It's a pure lifestyle statement. But the industry is changing rapidly, and now it's the efficient horizontal exhausts that are taking center stage. New models like the Kenworth T680, Peterbilt 579, Freightliner Cascadia, and Western Star 5700XE are offered from the factory with horizontal exhausts as the standard configuration. Vertical stacks are now optional, and the trend is clearly moving towards efficiency. And here's something interesting about driver psychology that companies study. Market research shows that younger drivers under 35 prefer horizontal exhaust because they associate them with modern technology and efficiency. Meanwhile, drivers with over 20 years of experience on the road prefer vertical stacks because they connect with them emotionally, linking them to trucking tradition. It's a generational clash within the same industry. Transport companies also have their preferences based on hard data. Large fleets prefer horizontal exhausts because they reduce measurable maintenance and fuel costs. Independent owner-operators prefer vertical stacks because they give them a distinctive identity on the road. A truck is their rolling business card. Fun fact number 5. In Australia, where distances are extreme and road trains can have up to 4 trailers, the debate between vertical and horizontal exhausts was settled with a unique middle ground solution. Many Australian trucks use dual exhaust systems, with a horizontal outlet for efficiency and a small vertical stack to disperse fumes away from the rear trailers where support drivers might be working. There are also important climate considerations. In regions with a lot of snow, like Canada or Scandinavia, horizontal exhausts can accumulate ice and become dangerously blocked. Vertical stacks avoid this problem by dispersing hot vapor before it can freeze. In dusty desert areas like the Middle East or Australia, horizontal exhausts can kick up clouds of dust that reduce visibility. Vertical stacks launch the gases high above the road, preventing this. These seem like minor details, but they affect daily operations. And then there's the difference in maintenance that mechanics know well. A vertical exhaust is easier to inspect visually from the outside. A horizontal exhaust requires the mechanic to get under the truck with lifting equipment, but the vertical one is more exposed to damage from low-hanging branches or structures in urban areas. The horizontal one is protected by the chassis. But here's something few are considering yet: on what will happen to exhausts when trucks become fully electric. Electric trucks don't need traditional exhausts because there's no combustion, but hydrogen trucks, which use fuel cells, do produce an exhaust, even if it's just water vapor. Will that vapor exit vertically or horizontally? Current prototypes like the Nikola Tre and the Hyundai Xcient use small horizontal exhausts because the vapor isn't toxic. They don't need height for safety. But some engineers argue that a large volume of vapor could create visibility problems in cold climates. Imagine a truck expelling clouds of white steam in the winter. It could reduce visibility for other drivers. That's why some experimental designs are considering short vertical exhausts for hydrogen trucks. Another interesting factor for the future is sound. Electric trucks are quiet, so too quiet according to some. European regulations already require electric vehicles to emit artificial sounds at low speeds to alert pedestrians. Some manufacturers are considering designing fake decorative exhausts that emit electronic sound. It sounds ridiculous, but it makes sense. Traditional truckers feel their rigs lose personality without the characteristic roar. A fake exhaust with speakers could satisfy that emotional need, and there are companies working on that. I'm not kidding. The transition will be gradual. Diesel trucks will continue to dominate for decades in certain regions, especially in Latin America, Africa, and parts of Asia, where the electrical infrastructure is limited. There, the traditional vertical exhausts will remain. But in Europe and North America, more and more fleets are ordering trucks with horizontal exhausts with the future in mind. because when they eventually replace those trucks with electric ones, the transition will be easier if the design is already modern. It's long-term strategic thinking. The next time you see a truck on the highway, you'll just have to follow the path of its exhaust to silently read the entire philosophy with which it was conceived. If it points to the sky, you'll see American tradition, individual freedom, and the priority of the independent driver. If it's hidden under the chassis, you'll see European efficiency, cost optimization, and the priority of the company. But the most important thing to understand is this: both are right in their own contexts, and both effectively solve real problems. There is no single correct answer, and only correct answers for specific situations, based on geography, economy, regulations, and culture. If this deep dive helped you better understand everything that goes on around a simple exhaust pipe, don't forget to support us with a like, and let me know in the comments what type of truck you prefer, and for what specific reasons. Also, share if you know any other fun facts about trucks. See you in the next video about the world of transportation.